Hi, it's February 16, 2020. I'm Todd Dunn, and this video is about my Victron SmartSolar 150/35 MPPT solar charge controller. I bought this charge controller to handle the output from my 1000 watt array, which consists of 6 12-volt panels wired in series. So given the series configuration, the open circuit voltage for my array is 6 times the individual panel open circuit voltage of 22.5 volts, so that works out to about 135 volts. So I need a solar charge controller that can handle at least 135 volt input voltage, hence the 150, which is the maximum input voltage of this charge controller. Also, I needed a charge controller that could handle a 1000 watt array going into a 24 volt battery bank. One characteristic of MPPT charge controllers is that the wattage of the solar array that they can handle goes up as the battery bank voltage goes up. This controller can handle 500 watts for a 12 volt battery bank, 1000 watts for a 24 volt battery bank, which is what I have, or 2000 watts for a 48 volt battery bank. So this one controller can handle a pretty big array if you're running your batteries at 48 volts. Okay, let's take a look at the controller itself. It is approximately 7 inches wide, about 5 inches high, and almost 3 inches deep. And if you look at it there, you can see the electrical connections at the bottom of the controller. The two connections on the left in this picture are the battery connections, and the two connections on the right go to the solar panels. What are the other connections? Well, there's no load connection like you'll find on some smaller capacity charge controllers. As a consequence, this has what's called virtual load, and I'm going to come back to that a little later when we talk about some more of the functionality of the charge controller. Now, let's take a look at the bottom side of the charge controller. And you can see the connections for the battery and the solar panels a little better here. And to the right of those, there's a little plug that has 4 pins. And that plug can be used for a couple of things. There's a jumper in there. You can move the jumper and change the programming, or at least some of the programming of the charge controller. Or you can take the jumper out completely and plug a cable into this charge controller, and that cable has multiple functions. If you buy one with an adapter to go to a serial port, you can plug it directly into your computer and access the full functionality of the charge controller using the Victron Connect program, which you can download direct from Victron. Or you can, by changing the programming in the controller a little bit, you can use that cable to control an external relay, which is what they mean by virtual load. And you can program the charge controller to turn the relay on and off based on battery voltage or other parameters. Or you can put that cable in and connect it to other systems in a Victron network. So it's quite functional, but you do have to program the controller for the different functions of that cable. Of course, you don't need the cable because this charge controller has Bluetooth, and it can talk to your Bluetooth device. It's limited to Android phones and Apple computers and Apple phones. So that is a big advantage of this controller. Now, Victron's other controllers, their Blue Solar series, can do the same thing if you buy an extra add-on Bluetooth dongle that plugs in to that Victron communication port that I just talked about. But this one doesn't need that. It's built in and it has a lot of functionality, which I'm going to talk about now. Okay, here's my smartphone, and I'm going to show you how to connect it to the controller with Bluetooth. Now there is an application called Victron Connect that you can download from the Google Play Store or the Apple Store, and it's free. Comes from Victron. I'm going to move this a little bit just to get a little more centered, and you can download that and run it on your phone. So you just tap it. Here's Victron Connect coming up. In a couple seconds, it's going to tell me which devices are connected to it. Now, I have two Victron devices. One is a Smart BMV, which is a battery monitoring system. I have the BMV 712, and here is my SmartSolar 15035. So I'm going to select it, and it's going to connect via Bluetooth. And there we go. Yep. That was because I'm using the default PIN code for connecting via Bluetooth, and I haven't gotten around to changing it yet. And it asks me that every time. Okay, here's the base display. Okay, the first thing that you'll see here is it shows you the output of your solar array. I have a 1,000 watt array connected to this. It's putting out 13 watts right now. A couple reasons for that. One, it's quite late in the afternoon. It's 3:30 here in Maine. The sun is low. It's actually down below the trees, and so we're just getting indirect light right now. And the other reason is that my batteries are currently fully charged, and the system is floating right now, and doesn't take much power to hold the batteries at float voltage. So the charge controller has adjusted the operating voltage of the solar panels up to near their open circuit value to minimize the output, so it gets just enough power to hold the batteries at float voltage. You can see it's changing fairly quickly. That's as the charge controller adjusts the voltage of the panels to maintain the desired output. And this is a fast charge controller. Then we've got a bunch of numbers. This first one here is the operating voltage for your solar array. That will change depending on light conditions and whether or not the charge controller is trying to maximize the amount of power needed, for example during bulk charging, or to keep the amount of power, adjust the level necessary to maintain the voltage of the battery bank at the float voltage. Here's the current coming from the panels. Here's the current voltage of the battery bank and the charge current going into the battery bank. You can see it's fluctuating a little bit here to maintain me right around 27.8 volts, which is float voltage. The next thing here is temperature. This is the temperature of the battery bank that it's getting from the battery bank temperature sensor. And I'm going to come back to that later. Down here is it says state, and over here float. That's the charge state. My battery banks are currently in float. We can move this up, and you can see down here it's got the virtual load output, which I have turned off. What is virtual load? Well, since this charge controller does not have load output terminals, what it has is what's called a virtual load, where you can connect an external relay to the Victron Connect communications port, and the charge controller will turn that relay on and off based on parameters that you define. Okay, what are the other things that it can show? This is the history display, and what it shows is output from your solar panels for the last 30 days. See it going back here. And in my array, on the days when it's low, those are days when the system was just maintaining the batteries at float voltage. Days when it's higher are days when I had my inverter turned on and was drawing power from the batteries, and the solar array consequently was powered up by the controller to try to keep up with that. Now, in each day's array output, you can touch it and see if I can get it to work, and it will tell you how long it was in bulk mode, how long it was in absorption mode, and how long it was in float mode. You can look at each day in the 30 days. It'll also tell you some data about your system. For example, yesterday when I was letting the system run my house basically for the day, my panels put out 1.87 kilowatts. Maximum panel output at any given time was 682 watts. And when the system went into float voltage, my maximum array voltage was 140 volts. It'll also tell you your battery. Minimum battery voltage yesterday was 25.59 volts, and maximum was 29.03 when the system achieved the maximum voltage during bulk charging. Down here finally you've got the lifetime total power that has gone through your charger, in my case 27 kilowatt hours. And finally you've got this function, which is a relatively new one. It's called Trends, and what it does is it allows you to see how different parameters are changing. Right now it's showing solar array output power in blue and battery voltage in red. You can change these. For example, I could change this to solar current, and we could look at how the solar current is changing. Over here I could, if I wanted, select battery current, and we'll see how the battery current is changing with the axis on the left side for whatever is in blue and the axis on the right for whatever is in red. Now those are the basic display functions of this controller. They're pretty sophisticated. There's a lot of information available to you on your phone. The other really important aspect of being able to communicate with the controller by Bluetooth is right here. When we push this up here to go into settings mode, and in here you can, for example, go to your battery mode, and you can tell it if you have an unusual battery voltage. You can set the battery voltage here. If it's 12, 24, or 48 volts, it'll auto detect it. This is your maximum charge current. You can lower that, but you can't raise it. We'll cancel that. And you can turn the charger on and off here if you want. And you can go in here and tell it what kind of battery you have. And it's got a number of different parameters to select different types of batteries using some pre-programmed parameters for the bulk absorption and float voltages and relative time of absorption charging. And you can also define those parameters to whatever you want, which makes this a very nice charge controller to use with a lithium battery bank. And you can set the absorption voltage, you can set the float voltage wherever you want, you can set equalization voltage if you want to use equalization, and you can turn equalization on and off. I have it turned off right now. And you can also adjust the temperature voltage compensation, and you can set the low voltage cutoff for your battery system. For example, if you were using a lithium battery, you could set the low voltage cutoff to somewhat higher value than what the BMS on the battery was set to if you didn't want to, say, discharge the battery by more than 80%. There's a lot of functionality here. On the this is in the battery part of the settings. Load output. Well, this, as I said, has a virtual output, and you can go in here and program how the charge controller is going to turn an external relay on and off via the Victron Connect port. And street light is if you had this connected to a street light, it can turn on and off as a function of whether or not it's night or day. You can also go here and program the Victron Connect port for whatever you want. Right now it's set for normal communication, and you can see you can have it send a lot of information depending on how you have it set up. And down here is where you would set your virtual load controls if that's what you wanted to use it for. And finally, get back, you've got what's called VE Smart Networking. This is a nice setup. If you have other Victron components that have Bluetooth connectivity, you can use smart networking to let them talk to each other. And this is something that is very useful. And in particular, I have my charge controller talking to my battery monitor because my battery temperature sensor is connected to the battery monitor rather than directly connected to the charge controller. So the charge controller is getting battery temperature information from the battery monitor via Bluetooth. And the reason I did that is that the temperature sensor for the battery monitor costs around $20, and the Bluetooth temperature sensor for the charge controller costs a bit over $40. So I was able to save myself $20+ by networking the two and using the temperature sensor that's connected to the battery monitor, rather than buying the more expensive temperature sensor that is specifically for the charge controller. So that covers most of the things that you can use this for to play with. And now let's talk a little bit about how it works. Okay, let's talk a little bit about how this Victron SmartSolar MPPT charge controller works. We've talked about some of the functionality, what its capacities are, and how you can program it or monitor your solar array output and your battery bank output via the Bluetooth application on the controller, which I find very useful because the controller itself only has 3 LEDs to communicate with you, and they basically can tell you a lot. And I do have a video that's linked in the description that tells you what those LEDs tell you by which ones are on and whether they're on continuously or blinking. And there are a bunch of different things. Anyway, how does this thing work? Well, first off, it's an MPPT charge controller. That means it's a maximum power point tracking charge controller, so it will adjust the operating voltage of your solar panel array to the voltage that is putting out the maximum power when you're in bulk charging mode. And it will adjust that up and down as required to put out the maximum amount of power. For example, early in the morning when you don't have much light, it'll operate at 1 voltage to get the maximum power. At noon, when you have maximum sunlight on your array, it'll go to the near the nominal maximum power point of your solar panels. And say once your batteries have achieved full charge and are just floating, it will push the array voltage up, which will decrease the output and just get enough power to keep the batteries at float voltage. Now that is a very important thing to have it do, because if it didn't do that, if it simply kept the system at maximum power point, even though the batteries are at float voltage and only need an amp or so to maintain that voltage, some charge controllers simply dump the excess wattage as heat. Now this one does not do that. What it does instead is adjust the voltage of the array so that the array only puts out the amount of power that's needed to maintain the batteries at float voltage. So it does not dump excess heat into the room. Now it does get a little bit warm when you're pushing a lot of power through it, but most of the time it's at room temperature and doesn't really change much. And that is, I think, a nice feature of this particular charge controller. I also like the fact that, as I said earlier, you can over-panel it. For example, in my next video, I'm going to be talking about solar array output here on the coast of Maine for a fixed array in February of 2020, and in particular yesterday, February 15. And I'm going to be talking about my array's performance. And I'll just say that yesterday the peak output from my solar array was 682 watts, as we saw earlier when we were looking at the Bluetooth display of the history of my system. And that's a 1,000 watt array, so if I had wanted to get more power out of my solar array, I could have maybe gone up to a 1,500 watt array and gotten closer to the 1,000 watts that the charge controller can transform into a charging voltage and current for my batteries. In other words, I could have over-paneled my system. Of course, in the summer, I would be throwing away the excess power, so yeah, it's a trade-off. So I'm very happy with the way it works. It's been very reliable, and I haven't had any issues with it at all. And this charge controller, although a little bit expensive, I think it has enough features to make it a very good choice for a larger array like I have. And I actually bought it when I was planning to go with a 48 volt battery bank and a 48 volt inverter. But in the end, for reasons of economy, I chose a less expensive 24 volt inverter, which I'm quite happy with. As if you look back a couple videos, I did a video on my Schneider 4024 24 volt 4000 watt inverter, and you can see what I had to say about it. So anyway, that's where we are right now with this Victron SmartSolar 150/35 MPPT solar charge controller. I hope that you found this video useful, and if you liked the video, please give me a thumbs up. If you haven't and you want to see more content on solar stuff and a lot of other stuff that I do, boating and all sorts of other things, please subscribe to my channel and click that notification bell in the lower right hand corner just below the video to get a notification of when my next video is posted. Thanks for watching.